This is a half-life problem, which is kind of a teacher favorite, which involves carbon-14 and carbon dating. The example states a wooden artifact from an ancient tomb contains 40% of the carbon-14 that is present in living trees. How long ago to the nearest year was the artifact made? And you're to use that the half-life of carbon-14 is 5,730 years. So this artifact is found, and they measure the amount of carbon-14 remaining in it, and then they compare that to kind of an average for living trees in the present, and they can use this to carbon date the artifact with a fair amount of accuracy. So there's a couple ways of doing it. We're going to do this using a shortcut presented in another video, and that is that for half-life model, we'll use this relationship here, where A is the initial amount and H is the half-life. All right, now this one is a bit tricky because the initial amount is not given to us explicitly. Actually, it's not given to us at all. But the half-life is given. So if we fill out what we know, we'll have m is equal to a times 1/2 to the t over 5730. Now the issue is we can't complete this task until we know what the a is, or we can get around knowing what the a is. So here's where the tricky bit comes in. This part right here, the 40%, what this tells us is that whatever the a is, the current level, the m, is 40% of a. That's what that means. So we can actually plug that in and find the answer to this question, that is the time that has passed. We can find that without having ever known what a is, simply by knowing that it's 40%. So we plug that in, we get 0.40a is equal to a times 1/2 to the t over 5730. And since we know that a is non-zero, we can cancel it from both sides through division. All right, so now what we're left with is the rather straightforward task of solving this exponential equation here. And we never had to know what the a is. So solving this exponential equation is pretty standard. You take the logarithm both sides, use the power rule, and then solve for the t. There are plenty of videos about those individual steps. But where you'll land is that t is 5,730 times the log of 0.4 divided by the log of 1/2. You punch that into a calculator and you get approximately 7,575 years ago.